Hello and welcome everyone. I am architect Nishitha and I am here to take another live session on architectural aptitude for all of you. I welcome you all at THiNC Institute of Design's online session, live session that helps you in preparation of your upcoming Nata exam. Here are the details of our upcoming Nata crash batches. You can find the dates on your screen and you can also find the contact number. So today I have brought a really important and technical topic for discussion with all of you. You already know that every week in every live session I bring some of the other new topic that helps in preparation of NATA exam for all of you. So this live session is no different, and after this session as well, there are other very important sessions planned for you all by other faculties. So stay tuned till the end. So the topic that I've brought for discussion today is climatology. Let me first start by introducing myself. I already know that a lot of you regular followers and viewers already know me. I'm architect Nishitha and I'm a conservation architect and heritage professional from India. And I take architecture awareness sessions at THiNC Institute of Design. The topic that we will be learning about today is climate and architecture. This topic is also known as climatology. Now you might be wondering that what is the need to study or understand climate if you are an architecture student? The answer is very simple. Everything that we design or every building that we plan has been planned or designed with respect to the understanding of local climate. Whether you are building a structure in a mountainous region, whether you're building in a plain, you're building in a plateau, or you're building near the sea or the ocean, you really need to take care of the local climate. You need to understand the local materials and you need to understand what is going to work in a particular kind of setting. And to be a good designer or a good architect, you need to have a very good working understanding of climatology and its importance in architecture. So today's session will be a basic, very brief discussion and understanding of this topic. It is very crucial for your NATA exam because in 2024 and 2025, so many questions have been asked on the basis of climatology in architecture. Many questions have been there on Sunpath as well. If you have seen any previous year question papers or if you have solved any mock test papers as well, then you might be knowing already that there are so many questions related to climate, climate sensitive architecture, the climatic zones, various climatic zones that are there in India and even in fact globally, the hemispheres, the sun path, and the sun diagram. Many questions are being asked on these topics this year as well, in 2025 as well. So many of our students have faced questions related to this topic. So let's first understand the basic meaning and definition of some key terms related to this topic. The first word being climate itself. A lot of people get confused between weather and climate. You know that there are these two separate terms, weather and climate. Climate means an integrated condition of weather over the years, over a very long period of time. The conditions that are there in a specific region, in a specific area or part of India, in fact, the overall weather condition for a long period of time is known as climate. Whereas when I talk about weather, weather is a very simplified and very temporary condition of the environment, and it is calculated only over a brief period of time. So for a small period of time, if we are looking at the atmospheric condition or the environmental condition, then it is called weather. If we are looking at the weather or environment conditions over a very long period of time and it does not change very rapidly, then it means we are talking about climate. So the entire world is divided into various climatic zones. If I talk about India as a country, you see there is so much geographical variation in India. There are so many various parts in India from north to south, east to west, and there are all these geographical variations. So because of all of these geographical variations, the country of India is divided into 6 climatic zones. And all these climatic zones have their own characteristics and all of them have their own requirements. If I talk about the architectural need in each and every place, that is why we will see that the regional or the vernacular architecture of Jammu and Kashmir will be different to the regional architecture of Gujarat or West Bengal. and the regional, local, or vernacular architecture of Bihar and Uttar Pradesh will be much different from the regional and vernacular architecture of Kerala. So all of this is because of the varying geography and the different climatic zones that are there in India. And a good architect knows and understands these various climatic conditions and builds accordingly. So all the information and the knowledge of climate helps a designer to build a house that filters out adverse climatic effects while simultaneously allowing those that are beneficial. The built form and arrangement of openings of a building can be suitably derived from the analysis or even the basic understanding of climate. Climate thus plays a very pivotal role in determining the design and construction of a building. Now, how do you understand the climatic condition of any zone? So there are various factors. By understanding these factors, you can study the climate of any area. These various factors affecting climate are solar radiation, ambient temperature, air humidity, precipitation, the wind flow or intensity of air in any place, the sky condition. Sky condition means whether the sky is very cloudy, whether the sky is clear, and if the sky is clear, the sun will shine very brightly in such areas. And the vegetation or the forest cover, how much vegetation growth is there in a place, or if there is no vegetation growth, like desert areas. So all of these climatic factors have different kind of impact in all these different zones or different climatic areas. And each of their impact decides what kind of architecture are we going to build in a particular place. What is going to be the material of construction? What is the roof type that we are going to use in any area? What is the thickness of the wall? What kind of flooring can we use there? And what kind of insulation or conducive materials are we going to use in a place? Everything is decided on the basis of the understanding of these climatic factors. So let's quickly go through each of these terms and understand what they mean. And I'll also show you 2 or 3 questions at the end that are related to this topic and that are commonly coming in Nata in the last 2 years. So let's understand solar radiation. To understand about solar radiation, you need to know about the sun path. Sun path is a diagram or a hypothetical study that we use to understand the movement of Earth around the sun. So it is called sun path, and hypothetically we believe that sun is moving, but all of us know that sun is not the one who moves. Actually, Earth revolves and rotates. But just for a basic understanding, we call it the sun path. And we have learned since childhood that the sun rises in east and it sets in the west. But very few people know that the sun, although it does rise from east and set in the west, it also is related to another direction apart from these two. Because when the sun is moving from east to west, it is not actually moving in a straight path. Its angle of movement is not 90 degrees. In fact, it is tilted slightly towards a different direction. So if I'm talking about northern hemisphere, in that hemisphere, the sun's tilt is in the southern direction. And if I talk about southern hemisphere, that is the lower part of the globe, then the sun's tilt in this hemisphere is in the northern direction. So basically, the tilt of the sun will be in the opposite direction to what hemisphere we are in. For example, India is in the northern hemisphere. So in the northern hemisphere, the sun's tilt will be in the south. This is why south is that direction in India which experiences maximum sunlight. Because when the sun is tilted towards a particular direction, at this point, it is the closest to the earth. And since it is closest to the earth, maximum amount of heat comes to the earth. When the sun is rising from east or setting in the west, the angle of light that is falling on the earth is very small, and the sun's rays are coming from very far apart. But when the sun is in the southern direction, that is almost at the noon time, around 12 noon or 1 p.m., the sun is the harshest because it is the closest. This makes south the hottest direction in Indian region. Similarly, if I talk about Australia, north will be the direction which will be the hottest. So this sun path is basically drawn according to the southern hemisphere, where the tilt of the earth is slightly towards the north. So you need to take note of this phenomena. The rising sun is in the east. It is considered as the mildest sun, or the mildest sun rays come in the morning when it's rising from the east. So east is considered a comparatively more pleasant direction. The setting sun is in the west, so it is also pleasant, but not as pleasant as the east. West is slightly harsher than east, and the harshest sun rays will be experienced in the south. If you understand this basic concept, it will become very easy for you to orient your buildings or plan a society or a township, because the building orientation depends a lot on the direction of the sun path. And north is the most favorable condition in the Indian subcontinent to make an opening, to make the entrance of the building, or to make the front facade of a building. So north and east are considered the best directions. Solar radiation is the radiation or the radiant energy that we receive from the sun. It is the intensity of sun rays falling per unit time, per unit area, and is usually expressed in watts per square meter. There are various instruments as well which are used to measure the solar radiation or the solar energy, like pyranometer, pyranometer, and the sunshine recorder. So this is the diagram of a pyranometer. So how the sun will interact with the building actually decides how warm or how pleasant your building will be. And even the devices like solar panels are planned according to the movement and direction of the sun and the orientation of your building. So where do you place a solar panel is also very well thought and calculated of. Now, we want good amount of sun and sun rays in cold areas. If I'm living in Himachal Pradesh or Uttarakhand or Jammu and Kashmir or Ladakh, in such areas, it is quite windy and in fact very cold for most of the year. So in such places, I want maximum solar radiation to enter my building. But if I'm living in a place like Madhya Pradesh, or if I'm living in Tamil Nadu, or if I'm living in West Bengal, I do not want excessive sun rays entering inside my building, because these areas are as it is very hot and humid. So in such areas, we do not want excessive sunlight. Rather, we want to protect our buildings from harsh sunlight. So you can see a few diagrams on your screen, and these three diagrams are showing you the effect of sun on building structure. So the first one, you can see a dry tree. You see that there is nothing to protect the opening of the building from the harsh sunlight. Hence, the direct sunlight is entering inside the building through the openings. Whereas in this image, which is there at the bottom, in this sketch on the left side, you can see a very green, very flourishing tree in front of the house. And there are some openings as well. You can see an opening in the ground floor and even an opening in the first floor. So the solar radiation is not directly entering inside the building. It is being protected. The openings are being protected by the foliage of the tree, which is a good practice to adopt in hot areas where there is very harsh solar radiation. So it also, the solar radiation of the sun path, it also affects the orientation of building. Orientation of building means that where the longer side of the building will be placed, where the opening of the building will be placed, where in which facade of the building are the main gate, the main windows and large openings will be placed, and which direction no openings or very less or very shaded openings will be present. All of this is decided by architects depending on the sun path. So sometimes we want direct sunlight to enter in our building, especially when it is winter, when it is cold. We want sunlight to enter in our building so that there is some warmth on the inside for thermal comfort. But during summers, we do not want any harsh sunlight to enter in, because it is as it is very hot, and we want our inner environment to be cool. Next is ambient temperature. Another factor that affects the climate of any region is ambient temperature. Ambient temperature is the temperature of air in a shaded but well ventilated enclosure. And the amount of airflow also affects a lot in how we are designing a building. If I am living in an area where there is good amount of airflow, then I can orient my windows in such a way that there is proper air circulation in my building. And if I'm living in an area where usually there are no or very less wind flow, then I need to plan accordingly and design a building which has good amount of air circulation, maybe in a natural way or also in an artificial way. Next is air humidity. Humidity is a major concern for most of the states in India. most places in India are either warm and humid or hot and humid. So in such places, we need to not just fight with the solar radiation, but we also need to mitigate the effects of humidity, because humidity can also make a person very irritable, and it can also make the environment very uncomfortable for a person to live in. Air humidity, which represents the amount of moisture present in the air. High humidity accompanied by high ambient temperature causes a lot of discomfort. To fight with this humidity, we actually put a lot of measures in a building. We place cross ventilation, because there are windows which help in cross ventilation. So we can place windows in opposite walls so that there is good amount of airflow, and the indoors of a room do not have high humidity. Next is precipitation. Precipitation is usually confused with rainfall, but precipitation not only is about rainfall, it is about everything that is falling in any form but is related to water or moisture. So it can be rainfall, it can be hail, it can be snow, it can be fog. The definition of precipitation in is any form of water, liquid or solid, falling from the sky. So if in any area there is high precipitation in any liquid or solid form, then we need to plan our buildings according to that. Uh, in places where there is heavy snowfall or heavy rainfall, we often make pitched roof or sloping roof so that the snow or rain does not settle on my roof and it glides very smoothly. Next is wind. Wind is the movement of air due to difference in atmospheric pressure. The movement of wind also plays a very big role in building planning and building designing. And the instrument through which we can understand the speed of wind or the amount of wind flowing in a particular place is known as anemometer. Next is sky conditions. So sky condition, as I already told you, means the presence of either a clear sky or cloudy cover over the sky. There are places in India which have clear sky. For example, Ladakh, where you can experience a clear sky, because of which there is good amount of solar radiation as well. But because of its altitude, it is a very cold place. And there are places in India which have very dense sky cover, like Himachal Pradesh. There is dense sky cover and it is on a great altitude. That is why it is extensively cold throughout the year, and there is even snowfall. And since the cloud cover is so much, because of that, the direct sun rays cannot enter the cities. So what do the people in Himachal Pradesh do? They make very large openings in their buildings so that they can capture as much sunlight as they can with the minimum amount of sunlight they are getting in their region. Next is temperature. Temperature is a very common word. You already know what temperature is. It is a physical quantity that expresses the subjective perceptions of hot and cold. And as I've already said, maximum places in India are either hot or warm. So this is something that we need to take care about when we are designing a building, especially in places which are hot throughout the year. Next is vegetation cover. The amount of greenery that is present around your site also plays a major role in deciding on the orientation. Sometimes because there is very good amount of vegetation and the right kind of trees are planted in my site, I can also give openings in the southern direction, which is usually very hot. I can also plan my doors, windows and other openings in south because there is a good amount of cover of trees. And in the absence of trees, I need to plant shaded openings even in north and east. For example, in desert areas, there all the openings are very shaded and protected because of the harsh sunlight and because of the absence of vegetation. Sometimes presence of vegetation also leads to more precipitation and also in turn leads to more humidity. So that is also something that we need to work on. So a deep understanding of all of these factors actually helps us in designing very productively for our site. Now, let me show you some questions that are related to this particular topic that come in the exam. So, in the beginning, as I had already told you, that there are 6 climatic zones in India. This was a question that was asked in Nata 2024. Which is the local climate of a desert region? So, you have to tell me what is the local climate of a desert region. Your options are hot and humid, cold and dry, hot and dry, and cold and humid. So what, according to you, is the local climate of a desert region? Can you answer this in the comments? If you know this, please let me know in the comments and I'll check if you have answered correctly. I'm repeating the options: hot and humid, cold and dry, hot and dry, and cold and humid. The right answer for this question is option C, hot and dry. So desert regions are present mostly in two areas in India. India has two types of deserts, first of all. First is the hot desert, which is the Thar desert, that is mostly present in Rajasthan and some parts of Gujarat. And then there is a cold desert in India, which is present in Ladakh. So I think India is the only country in the world which has both a cold desert and a hot desert. But if nothing specific is mentioned, then they are definitely talking about the hot desert. So in the hot desert in Rajasthan and some parts of Gujarat, the climatic condition is hot and dry. There is no humidity, no, like almost no to less amount of precipitation. That is why the climatic zone is hot and dry. Let me show you the next question that has come depending on this topic. Which clothing material is suitable to wear in Chennai? Your options are synthetic, polyester, cotton, and silk. So what is that material that can be easily worn in a place like Chennai? So think about the climatic condition of Chennai, or if you do not know specifically about the city, then think about the state or the region where it is in. It is also very close to the sea. What kind of fabric will be suitable here? Synthetic, polyester, cotton, or silk? The right answer here is C, that is cotton. So that will be the most suitable material to be worn in this region. So these type of questions can come. Once the question was asked on the tilt of the sun, the question was asking that what is the degree of tilt of the sun when it is moving from east to west. So such type of questions can also come. And as I was telling you in the beginning that there are 6 climatic zones in India, let me also tell you what are these 6 climatic zones. So you can write it down, and for now, as the time is almost going to end, I can only tell you the names. But if you want to learn more about them, you can join our upcoming crash batches so that we can learn about this topic in much detail. So please note down the 6 climatic zones in India. The first and the most common one is the hot and humid climatic zone that can be experienced in states like Tamil Nadu or even West Bengal, which are much closer to large water bodies. Their hot and humid climatic zone can be witnessed. Then the next one is what we just discussed, the hot and dry zone. So difference between these two is both of them are hot, but in one place there is humidity because of the presence of a large water body, and the next one there is dryness because of the presence of a large desert. So these are the two. Apart from these, there are cold and humid and cold and cloudy and cold and dry zones. Cold and cloudy zone is present in Jammu and Kashmir, is present in Himachal Pradesh, and the cold and dry region is present in Ladakh, which is a cold desert. There is no cloud cover. That is why there is. It is not cloudy. It is dry. And apart from these four, there are two more climatic zones. First one is the moderate climatic zone that you can experience in most parts of Chhattisgarh. You can experience this in Delhi. That is a moderate climatic zone where there is no excessiveness of any particular season. But these days, because of global warming, of course, we are experiencing more amount of heat. But in such places, the thing is that you will not experience any particular type of climate in excess. Another one is the composite climate zone. So composite climate zone is one such zone again where you will not experience, in the composite zone, you will experience almost every climate in a good amount. So my bad, I said Chhattisgarh for the previous one. Actually, Chhattisgarh is an example of the composite area where you will experience each and every type of climate in a good amount. You can experience winter, you can experience summer, and you can experience monsoon. All three in such areas. So Madhya Pradesh and Chhattisgarh, both of them have a composite kind of climate. And a good example for moderate climate will be Bangalore, where there will be no excessive amount of temperature or excessive heat won't be there, excessive monsoon will not be there, even excessive winter will not be there. Everything will be there at a moderate rate, and in such places it tends to rain at any time of the year. There is no specific season for monsoon. It can rain randomly. So this is the moderate climatic zone, and this is around hilly areas. That is where similar type of climate can also be experienced in Pune, which is present in Maharashtra. So these are the 6 climatic zones that you can see in India. So students, with that, I would like to conclude this session on climatology. If you want to discuss this topic in detail, then you need to join us in the full length classes. And I would now like to hand over the live session to the next faculty, that is Chandu sir, for your next session. Thanks for attending the session. If you have any doubts or any questions related to this particular topic, you can ask in the comments. Thank you. This is me, Architect Nishitha Joshi, ending the today's architecture awareness session. Let's meet again in the next slide.
Okay, thank you, ma'am. Good evening, all. So today we will be discussing topics which is very much crucial for Nata, such as speed, distance, time, and some connected topics for that. Okay, so I think we can directly get into the topics. So speed, distance, time. So in this particular chapter, we are paying attention to few things like equation for these things like average speed. So everyone know that speed equal to distance by time. Okay, speed equal to distance by time. So this is a very famous equation, and I think it's quite familiar from your school classes onwards. So next, we can start with the average speed. Speed average, that is equal to total distance by total time. So this is the average speed. So assume like you are traveling a distance d1 in time t1 and distance d2 in time 2. Then average speed. Okay, so speed average, this is the first equation for the average speed. So speed average, you can write like d1 plus d2 divided by total time t1 plus t2. Okay, so you can use this equation basically for finding average speed. But in certain situations, there will be only distance, maybe given like in terms of speed and time. Okay, I will be showing that. So speed equal to distance by time. So speed into time equals distance. Okay, so over here, speed average, you can find it like instead of D1, you can use like S1 T1. Instead of D2, you can use like S2 T2. Okay, speed to time to. Similarly, on the denominator, as like T1 plus T2 comes. Okay, this is one equation for finding average speed. Okay, this is the second one. So other one more equation is there. So over here, the third equation. So the third equation, at that time equals distance by speed. See, actually, I'm rearranging the same equation. Okay, same equation, speed equal to distance by time. I'm rearranging the same equation over here. So now there is no need to by heart all the equations together. Okay, just learn this equation and apply it appropriately. Okay, so over here, distance d1 plus d2 divided by d1 by s1 plus d2 by s2. Clear? That is speed average. So we got three equations. Okay. See, this is a case of two equations. Even you can extend to n number like speed and tn divided by tn. Even here too, etc. up to dn divided by etc. up to tn. Okay. The same you can proceed over here too. Okay. dn and dn by sn. Okay. So you can take it up to nth term. So that's it. These are the three equations. And some special cases also we should pay attention, like two equal distances. Two equal distances covered in two different time, or it covered in different time interval. So that is different time. Okay. So over here, speed average. Actually, we have this equation. We are going to take this equation. Okay. But here, D1 equals D2 equals D, because two equal distance. Okay. So over here, D1 plus D2, that is D plus D. Time, T1 plus T2. Okay. So over here, just a second. So just a second. So what are the data we have? Distance and covered in different time. Okay. So at that time, you can simply go for speed average. That is D plus D using this equation by T1 plus T2. Okay. So over here, you can easily find it like 2D divided by T1 plus T2. Okay. So if the same case, there is a small difference I am introducing. Two equal distances. Two equal distances covered with, I'm writing the remaining over here, two different speeds. Okay, here the speed is different. Earlier the time was different. So at that time, we should use this formula. Okay. So over here, speed average becomes D1. As I mentioned earlier, D1 equal to D2 equal to D. So D1 plus D2 means D plus D. D1 by S1, that is D by S1. D2 by S1, that is equal to D by S2. So over here, you can take that D common. So it becomes 2D. In the denominator, D common. So 1 by S1 plus 1 by S2. So D and D cancel. So speed average, that is equal to 2 divided by 1 by S1 plus 1 by S2. Okay. So this is the equation. And you can rearrange it. So actually, this equation we can use, or you can rearrange it like this: 2S1, S2 divided by S1 plus S2. Similarly, three equal distances. Three equal distances covered in different time. Okay. Sorry, a different speed. So three equal distances covered with the different speeds. So over here, speed average, we will be using this equation over here too. Here, D1 equals, D2 equals, D3 equals D. So it is like D plus D divided by D by S1 plus D by S2 plus D by S3. So speed average, that is equal to 3D divided by D into 1 by S1 plus 1 by S2 plus 1 by S3. Okay, so D and D cancelled. Okay, so finally you can use this equation, or you can rearrange it like this: 3 S, S2, S3, similar to this, divided by S1, S2, S2, S3, S3, S1. Okay, you can use this equation also. Okay, so this is the main equations involved in this particular chapter. Now we can try some questions. So over here, a car moves 300 kilometers at a speed of 45 kilometers per hour. And then it increases its speeds to 60 kilometers per hour to travel another 500 kilometers. So find the average. What are the things which is with us? Distance and speed. So over here, speed average D1 plus D2. divided by d1 by s1 plus d2 by s2. So we had used the equation which we had used, the third one which we had used earlier. Okay, so speed average. So over here d1 that is 300, d2 that is 500, d1 by s1 that is like 300 by 45 plus 500 by 60. Okay, so that is speed average. So now you can do some cancellations. So 300 zeros, you can take 100 outside. Okay, I'll be doing it over here. You can take 100 outside. So the numerator becomes 3 plus 5. And here also you can take 100 outside. So it becomes 3 by 45 plus 5 by 60. So 100 and 100 cancel. So it becomes 8 divided by 3 by 45. You can write like 1 by 15. And I'm taking 5 by 60 as like the same. On the next step, it become 1 by 15 become 4 by 60. Okay, I just take an LCM of 60. 5 by 60. So over here, 8 divided by 9 by 60. So that 60 will be going up. So 8 into 60 by 9, that is cancelling 20 by 3. So it is equal to 160 by 3. That is 53. And like when it is 53, so 160 3 times, just a second, 150 by 3 plus 10 by 3 we are doing. Okay, this is what happened here. So 53.33 and so on kilometer per hour. Okay, so I just split it for doing it in mind. So even you can do it like this also, 160 by 3. In this way also you can do it. Okay, so we can move on to the next question. So over here, for the annotated copies of this session, you can contact it in this number, and you can, for admissions also you can use. And we are having our online batches, which is starting by 10th and 22nd April. Okay, so tomorrow onwards we are starting a new batch, and on 22nd also we are starting another one. And offline batches, one more offline batch is starting by 7th May, and currently many batches are running, and you can inquire with them using this number regarding batches. Okay, because currently offline batches, I think in certain batches 2 or 3 days classes is being over, so you can join in that also. Okay, anyway, quick decisions you should make. So we can move on to the next question. Air car covers. Before that, we can do this one. A man, because they are involves 3 speeds. First of all, we can do it with 2 speeds. Okay. A man makes his upward journey at 16 km per hour and downward journey at 28 km per hour. What is his average speed? Okay. So speed average. That is equal to, we have a formula, 2s1 s2 divided by s1 plus s2. We have discussed this formula over here. Okay, we have it over here. Okay, the same formula we are going to use in this particular question. So speed average, 2s1 s2. 2 speed 1, 16. Speed 2, 28. Divided by 16 plus 28. Okay, so now it's like speed average. You can rewrite it like 2 into 16 into 28 divided by 44. Now you can cancel 44, 4, 11, 7. Okay, in this way you can do. So over here, 16 into 7. Okay, 16 into 7 is like 70, 42, 112. 112 into 2, 224 by 11. See, I'm splitting it like 220 by 11 plus 4 by 11. Okay. So the right answer will be like 20 and 4 by 11. 4 by 11 equal to 0.36 nearly. So 20.36 almost. Okay. That much kilometer per hour. Okay. So now we can do the previous question. A covers 1/3 of the journey at the speed of 10 kilometers per hour. And half of the rest at the speed of 20 kilometers per hour. And rest at the speed of 30 kilometers per hour. What is the average speed of A? What is the average speed of A? So over here, we don't know the entire distance. I'm taking it like D. So the entire distance is D. So A covers 1/3 of the journey. 1/3 of the journey means D by 3 is the distance. 1/3 of the journey. Okay. Total distance, I took it like D. So 1/3 of the journey is like D by 3. Okay. At the speed of 10 kilometers per hour. And half of the rest at the speed of 20 kilometers per hour. And rest at the speed of 30 kilometers per hour. So over here, half of the rest. First of all, we should know about the rest of the distance. Okay, so over here, half of rest. So what is the rest here? Half of D minus D by 3. That is half of 2D by 3. 2 cancel. So that means half of that rest means another D by 3. Okay, and rest. Okay, here and rest. So already total D on that 1 D by 3 gone, another D by 3 gone. So now remaining is D minus 2D by 3, that is equal to another D by 3. Okay, so rest is also D by 3. So here equal distances they are covering. Okay, at different speeds. So now you can use the formula for speed average when 3 equal distance covered at 3 different speeds. So over here, speed average, E divided by 1 by S1 plus 1 by S2 plus 1 by S3. So we can find that equation over here. You can find that equation over here. 3 divided by 1 by S1 plus 1 by S2 plus 1 by S3. Even you can use this equation also. Okay. For the easiness of using, I am using the middle equation. So over here, three divided by 1 by S1 means 1 by 10. 1 by S2 means 1 by 20. 1 by S3 means 1 by 30. Okay, that is 3 divided by. You can take an LCM of 60. So over here, 1 by 10 means 6 by 60, 3 by 60, 2 by 60. You can take the 60 over here. So speed average, that is equal to 3 into 60 divided by 11. So that is 180 by 11. So you can split it like 11. So 176. Okay. 176 plus 4 by 11. So that means this is 16 and 4 by 11 because 11 into 16 is 176. So average speed will be 16.36 kilometer per hour. Okay. We had seen a similar one. another 4/11 here also. Okay. So speed average. So 3 into 60. We took an LCM of 60, 10, 20, 30. Okay. So that's it. 16.36 kilometer per hour. So this is the case of average speed. Okay. But the speed questions you can find in other chapters also. Like over here, you can find bot and stream questions. Okay. So now you can use the same equation, speed equal to distance by time in different ways in bot. Okay. In bot and stream questions. So for that, we need to learn a basic figure. So this is our basic figure. Okay. So assume this is like a river. Okay. A river is flowing with a speed of stream. Okay. So the river is flowing with a speed of stream, which is equal to, I'm just assuming it like 2 meters per second. Okay. 2 meters per second is the speed of that river. And assume one boat is going up. Okay. Speed of boat. Assume it like 5 meters per second. Okay. So speed of upstream. Okay. Speed upstream. So speed SS stands for speed of stream. Speed of stream. And SB stands for speed of boat in still water. Okay. Speed of boat in still water. And speed upstream. And SD stands for speed downstream. Okay. So now we can do for speed upstream. So what is the upstream speed here? So 5 meters per second, 2 meters per second. So if my boat goes 5 meters in 1 second, the river push it back 2 meters in a second. So effectively 3 meters only. That means speed of boat minus speed of stream is happening here. Okay. In case of downstream speed. So I'm coming down along with that stream. So if I am having a 5 meters per second speed, then I'll be getting an added speed of 5 plus 2, 7. So speed of boat plus speed of stream. Okay. So two equations, very basic equations. So with the help of these two equations, we can make few more equations over here. So speed of boat in still water, downstream plus upstream by 2. Okay, this is the equation for solving speed of boat. So you can see here, speed of downstream, speed of boat plus speed of stream. Upstream, speed of boat minus speed of stream. So at that time, speed of streams will cut down and you will be getting a 2 speed of boat equal to downstream plus upstream. Okay, so when you bring the 2 downward, you will be getting this equation. So what is speed of stream? Downstream minus upstream by 2. Okay, so 2 sets of equation. This is a first set, very important. Even this one also very, very important. Okay, so now total time. Time means time upstream plus time downstream. Okay, what is time upstream? Distance by speed upstream. What is time downstream? Distance by speed downstream. Okay, another important equation. Okay, so this is the basic equations in this chapter and you can club it with this one. Okay, so now we can try some questions. Okay, a man can row a boat in a downstream at 12 kilometers per hour. and upstream at 8 kilometers per hour. Find the speed of the boat that the man can row in still water. See, we can use the equation for speed of boat in still water. You can directly use that. Okay. Downstream plus upstream by 2. Okay. So speed of boat. What is downstream speed? 12 kilometer. Upstream speed 8 kilometer by 2. Okay. Very silly question. 20 by 2, 10 kilometer per hour. Okay. 10 kilometer per hour. So let's move on to the next question. A boat running downstream covers a distance of 20 kilometers in 2 hours. While it covers the same distance, that means 20 kilometers upstream in 5 hours. Speed of the boat in still water. Okay, so first of all, we should find running downstream speed. 20 kilometers in 2 hours, that is 10 kilometers per hour. Upstream speed, 20 kilometers in 5 hours. Okay, so that is 4 kilometers per hour. And speed of boat in still water, downstream plus upstream by 2. That is 10 plus 4 divided by 2. So that is 7. Same equation, but this was easy. They were asked in a direct and easy way. Some indirectness is there in this question. Okay, so that is the difference. So now over here, a man can swim 3 kilometers per hour in still water. Okay, so a man can swim 3 kilometers per hour in still water if the velocity of the stream is 2 kilometers per hour. The time taken by him to swim to a place 10 kilometers upstream and back. Okay, so time, that is time upstream plus time downstream. That means distance by speed upstream plus distance by speed downstream. This is the formula for the time. So what is the distance here? 10. Okay, place 10 kilometers upstream. So we got the values of D. Downstream speed and upstream speed, that is unknown. So a man can swim 3 kilometers per hour in still water, velocity of the stream. So over here, speed upstream will be like 3 minus 2. Okay, so this is the speed of boat. This is the speed of stream. Okay, you can take it like this. A person is swimming. I'm comparing it with the boat. So that is equal to 1. Sorry. And speed downstream, 1 kilometer per hour. Downstream, 3 plus 2. That is 5 kilometer per hour. Okay. So over here, 10 by speed upstream, 10 by 1. Downstream, 10 by 5. That is 10 plus 2, 12. Okay. 10 plus 2, 12. So the right answer is 12 hours. Okay. So the right answer is 12 hours. So we can move on to the next question. So a man can row at 5 kilometers per hour in still water. If the velocity of the current is 1 kilometer per hour and it takes him 1 hour to row to a place and come back, how far is the place? So a man can row at 5 kilometers per hour in still water. So speed of boat, 5 kilometers per hour. Speed of stream, 1 kilometer per hour. Okay, so the total time given 1 hour. See, we have the formula. The formula is like this. Time equals time upstream plus time downstream. So what is the time upstream? Distance by speed upstream plus distance by speed downstream. Total time D, 1 hour. Distance, unknown. Upstream speed, see speed upstream. 5 minus 1 equal to 4. Speed downstream, 5 plus 1 equal to 6 kilometer per hour. And over here also 4 kilometer per hour. So upstream speed you can use like 4. Downstream speed you can use like 6. So 1 equals, you can take the D common, 1 by 4 plus 1 by 6. Okay, so that is 1 equals D into 6 plus 4 by 24. So over here, 1 is equal to D into 10 by 24. So 24 by 10 equal to distance D. That is equal to 2.4 kilometer per hour. Okay, so in this way we can find the distance. So now we can try another question. And that from another chapter. Okay, so rail or train related problems. So there is only one equation which you can use to solve questions from this particular area. So train related problems. Train related problems. Okay. So we have the basic equation. Speed equal to distance by time. Actually, we are learning a single chapter. Speed equals distance, speed, distance, and time. And these are the extended versions of that chapter only. Okay, so speed equal to distance by time. So when it is the case of train, average speed, you can take like total distance. Okay, so just a second. So over here, in case of a train, you can write like speed into time equal to distance. So these are the base equation. So instead of speed, when it comes to train, it becomes relative speed. So relative speed into time equal to total distance. Okay. So relative speed into time equals total distance. So what is relative speed? Relative speed. So when the train is coming in opposite directions, train and object, okay, speed of train and speed of object. If they are in opposite directions, then we will take the speed as speed of train plus speed of object. That is why when you are traveling in a train, if you find a train which is coming in opposite direction and you feel like that the train is having a very enormous speed, this is due to the adding up of speeds of train. Similarly, if it is in the same direction, speed of train minus speed of object. Okay, that is relative speed. So now comes over here, speed of train plus or minus speed of object you can take for relative speed into time. What is total distance? So over here, assume we have a railway platform over here. Okay, assume we have a railway platform over here and we have another train. So this is our train. Okay. So we have a train like this. Sorry. So this is the length of train. You can say it like 200 meter. And this is the length of platform. Okay. This is the length of the platform. So the length of the platform that is equal to 500 meter. Length of the train equal to 200 meter. Length of the platform that is equal to 500 meter. So over here, total distance. Okay. Total distance is equal to length of the platform plus length of the train. Okay. Length of the platform plus length of the train. That is the total distance. Because if a question comes, see, this is the train. It reaches the platform. Now the train needs to completely come out of the platform. So this train travels 200 meter, it will reach here. Okay. Another 300, it will reach here, engine. So the engine has to travel another 200 meter to come out of this. So from here to here, the engine should travel the entire length of platform to length of train. So that is total distance, length of platform, sorry, length of object plus length of train, because here the length of platform, that is the length of object. Okay, so that is the base equation. And this particular equation is widely used. And this is the one and only equation which you can relate to solve the question from this particular chapter. So now some special cases we should discuss. So the special cases is like this. Speed of train, sorry, speed of object will be 0 in certain conditions. Speed of object becomes 0 because non-moving objects like post, platform, post means lamp post, signal post, etc., platform, etc., then speed of object will be 0. When it is a finite value, it will be a finite value when it like object like moving cars, moving objects, any moving objects like cars, man, etc. came into being, or other train, they will be having a definite speed. Similarly, length of object is also having similar special cases. Okay, so first one, 0 length. Negligible width things. Okay, negligible width things like man, post, etc. is having length of object 0. And other things like they are having finite value. Things like platform, tunnel, platform, tunnel, etc. will be having a finite value. Even other train, they are having a finite value. Okay, so this is the one and only equation which you can use to solve question from this particular area. So we had the base equation, speed into time equal to distance. From this equation, you can derive this one. Instead of speed, you can give relative speed because trains are having relative speeds. Okay, so relative speeds into time, that is equal to total distance. So relative speed of train plus or minus speed of object. Why this plus or minus? Plus when opposite, minus when same direction. That is why this plus or minus. Okay. Then length, total distance. Length of object plus length of train, because the engine have to travel this much distance. When it reaches, this is the contact point with the platform. Okay. Then it should travel 500 meter to reach the engine here. So the engine should travel another 200 meter for taking the train completely outside. That is why it is like length of train plus length of object. Okay. and special cases also we had already seen. Speed of object becomes zero when stationary objects like post, platform came into being, and it will be having a finite value when moving objects like cars, man, even other train is possible, other train, all are possible. Okay, and length of object becomes zero when it is like negligible with things like post, man, etc., and platform, tunnel, other train, bridge. These things are having finite value of the length of object. Okay, hope you got the equations. Now we can try some problems based on this. You guys can put your response in the chat. A train 300-meter long. Okay, a train. Suvini, good evening, good evening. Okay, good evening, Saurav. So a train 300-meter long is running at a speed of 25 meter per second. Okay, it will cross a bridge in 200 meter in how many seconds? So you can use that formula directly. Just try. I'll write the formula here. Speed of train plus or minus speed of object into time, that is equal to length of object plus length of train. This is our one and only equation. Okay, this is our one and only equation. Okay, I didn't see Saurav's good evening as well as Suvini. Little bit late. Okay, so now you guys can solve this. Now you guys can solve this. Okay, over here, speed of train. Do we have that? What are the things which we have? Train, 300-meter long. Length of train we have. Next, at a speed of 25 meter per second. Speed of train we have. It will cross a bridge. It is a bridge. So speed of object, 0. Speed of object, 0. Length of object we have. So speed of train, substitute for 25 meter per second. Speed of object, 0. Okay, so we should need to consider that. Okay, only speed of train is available. Into time, length of object, is it available? Yes, 200 meter. Length of train, is it available? Yes, 300 meter. So time equals 500 by 25. Cancel this. You will get 20 here. 20 seconds. Okay. 20 seconds is the right answer, option C. So we didn't do anything else. Simply rely on this equation. Okay. Sometimes you will be getting it in different units. At that time, you should change the units. Now, a train is moving at a speed of 132 kilometers per hour. We need a conversion here. Okay. We need to convert it into meter per second. Okay, we can do it later. If the length of the train is 110 meter, how long will it take to cross railway platform? Speed of object, 0. This is length of object. This is speed of train. Okay, this is length of train. Okay, the demand of the question is to find the T. Now we can write the formula. Speed of train plus or minus speed of object into time equals length of object plus length of train. So speed of train, do we have the value? 132 kilometer per hour. So 132 into 1 kilometer per hour equals 5 by 18 meter per second. But I know that many of you are having confusion. For them, I can give you a technique. So what is 1 kilometer? 1000 meter. What is 1 hour? How many seconds? Because we need to convert to meter per second. 60 minutes, 60 seconds. Okay. So total 3600. I'm writing it like this. So you can cancel zeros. If you have a confusion, you can do like this. So 10 by 18, you can cancel here. 5 3. So that is 5 by 18 meter per second. Okay. So over here, we are taking that 5 by 18. Okay. Into time. Length of object, that is 110. Length of train, 165. Time. Okay. 132 and 18 you can cancel. So 132 and I will be doing it somewhere over here. 132 into 5 by 18. So 18, 132. This is like 61, sorry, 66. And over here, it is like 9. Okay. So it is like 66 into 5 by 9. T, that is equal to 110 plus 165. So that is equal to 275. 110, there is 11 times 11. You can cut with 11 here. Even 165 also, you can cut with the 11 because 165, 55 into 11. So this is like 15 times you can find 11 here. Other side 10. So if you cut this with 11, you will be getting it like 25. Over here, you will get it like 6. Okay. So 30 into 5 by 9, that is equal to t equal to 25. So you can cancel here 1, 5. So it is equal to 30 by 9 equal to 30t by 9 equal to 5. Again, you can cancel. So you will be getting like 6 times here. So 6 by 9. Sorry, just a second. Just a second, a calculation error. So 132, you can do it like 66 into 5 by 9 because we have take the half. Okay, into time, that is equal to 275. Okay, so time equals 275 into 9 divided by 66 into 5. Okay, so 66 into 5 means you can take it like 110, 165, 275. Okay, so you can take this 66. 66 and 275 you can cancel. This is 6. And here you are going to get it like 25. Okay, 25 into 11. We used to cut with the 11. Okay, so 9 and 6 you can cancel. 9 and 6, when you cancel, you will be getting it like 3 and 2. 5 and 25 you cancel, you will get 5 into 3. So it is like 15 by 2. That is 7.5 seconds. Option B was right. Okay, option B was the right answer. So now we can move on to the next. So two trains, 137 meter and 163 meter in length, are running towards each other. They are coming opposite. Two trains. Okay, I'm taking the second train as an object. On parallel tracks, okay. 137. We have got the length of train, length of object. One at the rate of 42 km per hour. Speed of a train, 48. Speed of object. Sorry. In what time will they be clear of each other from the moment they meet? Okay. From the moment when they meet. So same, we are using the same equation. So length of train plus length of object. So speed of train 42 kilometer per hour. Okay, 42 kilometer per hour plus 48 kilometer per hour. We need to convert it into meter per second. So we introduce 5/18 here. Into time. Length of train 137. Length of object 163. So it is like 90 into 5/18 into time equals 300. When you cut this, you'll be getting 5. 25t equals 300. Time equals 300 by 25. Okay, so the right answer will be 100 4 times. So it is 12. 12 seconds is the right answer. Okay, now we can try the next one. A question which is very similar to this one. So a train 110 meter in length travels at 60 kilometer per hour. Okay, so this is the length of train. This is the speed of train. Does it take passing a man? Length of object 0. Speed of object given. So we have using the formula speed of train plus or minus speed of object into time equals length of train plus length of object. So speed of train 60 and a man is walking against the train. Okay, so 60 plus 6. This is in kilometer per hour. So we should convert it into meter per second, 5/18. Into time. What is length of train? 110. What is length of object? 0. So 66 into 5/18 into t equals 110. Okay, so now t equals 110 into 18 divided by 66 into 5. You can divide with 11. So here you will get 10. Here you will get 6. 18 and 6, you will get 3. 5, 10, 2. 2 into 3. Time equals 6. So option A, 6 seconds is the right answer. Okay. So that's why I told you that the previous question was exactly same to this. There was only one difference. There was another train involved. Okay. So now we can do a little bit elevated question. A train passes an electric pole in 10 seconds. Okay. And a platform 120 meter long in 18 seconds. So that electric pole is on this platform. So over here, speed of train is equal. Okay, speed of train, same in both cases. So over here, find the length of the train. So over here, speed of train plus or minus speed of object into time equals length of train plus length of object. This is our basic equation. So what is speed of train here? Unknown. Speed of object. So over here, the electric pole and platform is having no speed. Into time, it took, this is the case of pole. Okay, 10 seconds to cross a pole. Okay, and that is equal to length of train because pole is having length of object equal to 0. Okay, so in case of pod, length of object is 0. So speed of train equals length of train by 10. Next, instead of pole, now we are using platform. Platform. Okay, same equation. Speed of train unknown and the speed of object is 0. It is platform. Into 18 seconds to cross the platform. So length of train unknown. But we know the length of object. Okay, that is 120 meter. So now speed of train equals length of train plus 120 by 18. Okay, our train. So I just introduced that train once again for separation. So this is the first equation. This is a second equation. You can equate 1 and 2. So length of train by 10 equals length of train plus 120 by 18. Okay. So now 18 into length of train equals 10 into length of train plus 120. So 18 length of train equals 10 length of train plus 1200. So you can bring the length of 10 length of train here. So 18 length of train minus 10 length of train, that is 1200. So the difference is 8 length of train equals 1200. So length of train 1200 divided by 8. Okay. So that is the length of the train. So 1200. So in 120, 15 times. 8 is there for the 15 times. Just a second. 120, 8 is there for the 15 times. So the right answer will be 150. That is the length of the train. Okay. So today we see different types. Okay. We see different types of questions which is connected to a single topic, speed, or speed equal to distance by time, a single formula, but it's multiple versions. We see it for average speed. We had seen it for boat. We had used that for boat, and we had seen it for train. See, all these are connected. Okay. If in a Nata question paper, if a question from average speed comes, they will be definitely asking question from these chapters also. Okay. Because usually they are taking questions in such a manner. See, many questions you can expect from a single chapter. Okay. Sometimes there will be no question from a single chapter. Like some chapters, they will be not asking in certain Nata sessions. In certain Nata sessions, they are asking that exact chapter they had omitted earlier. Okay. This is happening here. So speed of average, boat and train. So practice as much as questions as possible. And for the annotated copies of today's session, you can contact in this number provided over here, as well as for the online classes and queries. You can use this particular number. Okay. Anyway, we can wind up over here, guys. Thank you all. We'll meet again in the next session with another class. Bye all.